Dave Bennett is a senior solutions engineer with Indykite. Has anyone heard of Indykite before? Okay, you got a couple hands. Love to see it. Love to see it. Awesome. Okay, so Dave himself is actually an expert in identity management, and he's focused on all the aspects of identity management projects ranging from product selection to implementation. So he's today going to present on context graphs as the control plane, right? As the control plane for your agentic enterprise. So he's going to dive into how context graphs can use AI as rich context and embedded control, which is required to govern every action in real time, ensuring precision, traceability, and operational trust at scale. So we're about to get started here. Dave is going to join us. And in the meantime, while he's getting started, and he's probably going to beat me to it, as he always does, but we're going to get started, and everyone, a round of applause for Dave. Woo!
All right, Jessica didn't want the mic, but I'm anchored to the desk, so. Thanks for coming, everybody. My name is Dave Bennett. I'm a solution engineer at Indykite. I'm going to be presenting to you on context graphs as the control plane for the agentic enterprise. So what I'm going to do tonight is I'm just going to burn through a couple slides pretty quick and then jump into like a reference architecture for what I'm talking about and then show like a little demo. So here we go. So at Indykite, we believe that context graphs are a great way to organize multi-agent systems. So we think that it's important to decouple the agent intelligence from the agent governance. So decoupling allows enterprises to change layers without rebuilding governance every time. New agents can be introduced without fragmenting data access and policies. As the stack evolves, architecture remains flexible enough to evolve. It's not just enough to have data, now we need to operationalize it. And I think this is kind of where we're going with like Jessica and some of Will's presentations. But in order to make AI deployable with the least amount of friction, we need to up our game in the control layer. Traditional knowledge graphs encode facts as triples. Employee A works in department B, but context graphs add provenance and temporal validity. And additionally, as you've seen, decisions can be materialized in the graph in a way that makes them easy to query. And this is the essential sort of je ne sais quoi of the graph and why the decision trace makes so much sense in the graph. You can trace that lineage back through many decisions. The context graph is dynamic control plane. We're moving from static permissions to dynamic intent-aware governance. Context graphs give us the capacity to explain why or how something occurred or in what sequence something happened. If agents don't have fixed roles, they execute tasks that vary by user intent, data sensitivity, environment, trust signals. In the Indykite knowledge-based access control, we evaluate all those things at runtime, not just a static role label. So at Indykite, we see context graphs not as a nice to have, but the control plane for the agentic enterprise. Without it, safe deployment's not possible. Agents need grounded, traceable decisions to handle complexity. We're bridging the gap between embedding trust directly into the graph, real-time authorization, provenance, identity verification, fine-grained access control. Okay. So the world we see today is fragmented. There's no clear view of which agents exist, and this is the enterprise world I'm talking about. These are the people that I talk to every day, and they're like, okay, we want to do all these things, and we have a few agents now, and we're experimenting, and we're going to have a million different routes through our thousands of agents in a few years. How do we begin to manage this? And so, we're making the play for managing the agentic workflow. So there's people, these things are scattered. No one knows who owns them or who's using them. Identity and data access policies aren't enforced or uniformly across agents, tools, and platforms in the enterprise. We have difficulty enforcing least privileged things that we've come to sort of think of as motherhood and apple pie in the identity world recently. These things are sort of an afterthought right now as everybody sort of lunges forward, super fast, trying to achieve sort of like brand new insights and gains and, all kinds of efficiencies. They lack human oversight and proper delegation. Explosions of internal tools and external MCP servers creates confusion, and we risk a lot of unintended data exposure. Okay, we want to move from governing data to putting well-governed data into action. So we want to give agents identity. Agents are materialized in the graph. Ownership is maintained through adjacent graph objects. And at the end of the day, we have now a catalog of agent skills and tools. We want to manage delegated authority properly. We're using the OAuth token exchange specification for using this for delegation. Right now, in our demo that I'm going to show you, we're using Curity as a third-party IDP, but Curity supports this delegation token exchange, and you'll see how that works in a minute. Agents have no standing privilege in our world, but instead get their context from a calling human or another calling agent. We always have a full calling chain from the first user to the last agent, all the way through. And we want to have dynamic policy enforcement, agentic workflows, and the calling user context. Okay, so that was a lot. Here we go, reference architecture. This is the part that's better, I think, probably for everybody. But this is kind of where I'm getting at. So if you look here in the bottom right-hand corner, this is kind of the thing I'm describing. We have in the bottom left-hand corner a series of sort of enterprise systems like Workday, SharePoint, Salesforce. These are things that exist in every enterprise. But all of them, and if you look at, like, again, we are going back to the Foundation Capital story, but the Foundation Capital story, I think the reason it resonated with so many people is it's very true. We're looking to try to do something right now, and the data is there, but it is all sort of focused in one place, and it isn't knowledge. We believe that bringing the data from, shards of data from different systems into the Indykite control plane through, our capture API, we can then amass different pieces of information from different systems and build an important, context for understanding the enterprise. So, and then here on the bottom right-hand side, you'll see I've got like an external reference thing, the Indykite control plane. We don't have to actually just materialize all the data in the graph. Sometimes the data is best served being left outside the graph. It's temporal or telemetry data that maybe needs to be accessed at one point in time and not all the time. And we don't need to use it to fill up our graph with all this information. So we can reach out and call various APIs to get what information we need from places. And here I'm going to get a stock quote. It's a little example I have. So if I move up here over to the left edge, we've got a human, and then we've got an agent gateway, an orchestrator agent, and another gateway, and another retriever. So these three things are going to, basically our user is going to try to get things from them, but we're going to use the Indykite agent gateway to sort of make sure that it's the right user in the right workflow, calling the right things. So the user, when they make a call, they are authenticated as themselves. They have their own token. So again, we're getting this through the IDP up here. The IDP has issued a standard OAuth token for our user, our human user. And then they want to, type in something in the chatbot and fill in a prompt and get some response back. So that information then flows to the Indykite agent gateway, and the Indykite agent gateway is like, oh, okay, cool. This is, Joe wants something. I know that the agent one, I know their token and their identity, and I'm going to take these two tokens and I'm going to give them to my IDP. And then again, in the case that, again, in our example, this is going to be Curity. And again, it's anybody that's going to, any third-party sort of IDP that is going to be OAuth compliant and support the token exchange flow. Anyways, both these tokens go into the IDP, and it says, okay, now I'm going to grant and mint a new token where the calling human is the subject of that token, and the agent is now the actor of that token. So the actor is going to act on behalf of the calling human. So now the agent gateway's got this chain, this delegation chain baked into the token, and it's like, okay, now I know that, Joe called agent 1. Is this a valid workflow? So it's going to call back into the Indykite control plane, make sure that this is a valid workflow, and it's like, if it is a valid workflow, then it's going to go and actually see if Joe is actually allowed to call that workflow. If Joe's allowed to call that workflow, it's going to be like, okay, my work here is kind of done. I'm going to let this request go through to agent 1. Agent 1 is like, okay, well, this is actually a retrieval request. I know I need to send this down to agent 2. And so this whole thing repeats again. But this time, the calling token is the new augmented token that has the subject from the original user and the actor, who is agent 1. So now agent 1 is acting on behalf of the subject. We call agent 2. Agent 2 is like, oh, okay, cool. Or I should say agent 2 gateway is like, oh, I got another request. I know I'm representing agent 2. I'm going to send this new token and my agent 2 token up to the IDP. It's going to go do the token exchange, bring them back. Indicate, the gateway is going to go say, oh, okay, is Joe to agent 1 to agent 2 a valid workflow that I know about? Oh, yes, it is. Okay. Is Joe actually allowed to call that workflow? Okay, perfect. I'm going to let that prompt proceed. Now that prompt's gone off to agent 2 retriever, and it's like, okay, now I'm going to do some retrieval against my MCP server. So it's going to, list its queries or do an authorization call. In our case, maybe it's going to do what we call a CIQ call or a context IQ query and query the actual control plane itself for something. And it's going to do that inside the context of the token. So in that token, we have all the actors. We have agent 2, agent 1, and the original subject. So we can provide like a full context of calling. So even though Joe might have access to all kinds of things, maybe in the little slice of this transaction, Joe plus agent 2 plus agent 1 only has this much access. So we can immediately sort of, with the right information in the graph and knowing about who the calling agents are, we can scope down like what the agent is actually going to be able to do. Whew, that was a lot. Anyway, I wanted to go fast and get through that, but now I'm going to just jump into a little demo and see if I can make this actually work. So hang on. I have to go up here and minimize this. All right, one thing done. All right, and I can just squish this over here. Okay, and here we go. Okay, so here we have this picture represents basically what I have running on my laptop and a couple other things. But essentially, agent 1 is going to be an orchestrator agent. Agent 2 is going to be a retriever. And this is like an Indykite little chatbot. So we built these things to show off sort of the gateway and the MCP server. So here we go. I am going to now, actually, you know what? I forgot one thing that I wanted to show you. You know what? We'll do it after. Basically, though, I have a couple of fictitious users. One is Rebecca, and she's a customer of a company called KBAC. Can everybody hear me all right? And then I have another user named Leslie. And Leslie is a customer service rep for KBAC. And then I have another user named Roy, who is also at KBAC and is a trader. And now Jessica's just got her credit card bill and realized that she was late making her payment and has received a fine. And she wants to phone KBAC and see if she can get a refund on her stuff. So she calls up KBAC and she is now talking to Leslie. And so Leslie's going to log in to the Indicite control plane. And here you can see this is Curity. So Leslie's logging in and getting bounced out to Curity. And this is Leslie's logged in. There we go. Okay, so now Leslie logged in. What's running over here on the right-hand side of the screen is, this here is the retriever agent. And basically what's going to happen is it's going to get some instructions eventually. And here in the right-hand nav of the chatbot is basically agent communication with the gateways. So if I go, I'm going to just see what Leslie wants to know is what policy documents pertain to refunds. So Leslie's got this request from Rebecca, who's kind of a little upset because she's a good customer of the bank, and he wants to know what documents we have. So we've got some documents in the knowledge graph that have come in from SharePoint. This data is basically ingested and tagged, and so we know a little bit about it. And what's happened here in the right-hand nav is the orchestrator agents got a hold of this, and it said, okay, here you can see I'm forwarding this request, and then the refresh token's received. The token then, we can test to see whether the Leslie Indicite agent 2 chain is valid, and then it sees to see if Leslie is actually allowed to call that, and sure enough, he is. I'm sorry, but an error occurred when trying to retrieve information about the policy document. That's awesome. Demos are fantastic. Let's try one more time. What's happened, though, is the request has gone through both agent gateways and has actually hit the MCP server, or we're trying to hit the MCP server. And it's doing something. Oh, look, I got a response. Yay. All right, so basically, Leslie wanted to find out information about things, and he found out that there is actually a policy document pertaining to customer refunds. So now he wants to see if that has actually been used in a past decision. So we're going to then put this in here, and Leslie's going to run this. And again, this is going to pass through both agent gateways to the second retriever agent, and the retriever agent's going to use the MCP server to retrieve a CIQ query from the Indykite control plane that's looking for past decisions that might help Leslie. Okay, and we did find a past decision. And so we can see in this decision here that Leslie, when his actually now boss, Flo Collins, who is a CSR2, which is what Leslie is right now, she has previously approved something for a customer. So Leslie feels pretty comfortable now that he can go into the credit system, give Rebecca a credit that she deserves, and then he can go and then enter that in the CRM system, and that decision then will then eventually flow down to the knowledge graph, the context graph, and form new sort of informational knowledge about what actually transpired, so that in future decisions we can factor in those things. So now Rebecca's got this problem solved. She wants to go spend some money. She feels like she should buy some NVIDIA shares. So now she's gotten handed over to Roy, and Roy works in trading stuff. And Roy is going to log in again as himself. Again, we're back out to Curity. All these things are generating OAuth 2 tokens. They all have the subject of the user. And maybe I can log in. Oh, that's not good. Let me try that again. Log in. All right. There we go, that's better. Okay, so now Roy knows that Rebecca actually has a limit on her account as to how much she can spend every day, but she really wants these NVIDIA shares because everybody does. And so Roy's gonna ask, this is a little bit contrived, I know, but she's gonna ask how many NVIDIA shares can Rebecca purchase for her? And so what's happening is it's going out to, the MCP server is calling that query to look for a stock quote on the internet. So even though our agent doesn't have any internet access, it's getting a very specific stock quote from the Indykite platform through that external call. So that's one call that the MCP server is making. The other call the MCP server is making is to see what Rebecca's limit actually is. And so then it's just dividing through by the share price. And I can see now that Rebecca can purchase 54 shares in NVIDIA. When I ran through this demo this morning, Rebecca could only purchase 53, so she's much better off. Anyway, this is just fairly contrived sort of examples, but one thing I wanted to show is that, even though Roy and Leslie work for the same company and have worked with the same customer, their contexts in dealing with her are different, and the MCP server respects that. So when I tried to execute something like one of the calls that Leslie did, maybe what policy documents pertain to refunds, which is a pretty benign thing, but I know that in the graph, these policy documents only apply to Leslie's department and not to Roy's department. So when I fire this prompt, I'm expecting to get sort of a negative result back, and I'm pretty sure I'm going to get one. But it is LLM land, so you never know. But fingers crossed. Yeah, sure enough. I was unable to process your request, check the audit log. But basically what happened was the MCP server found the exact same query, but called it. But this time it called it as that third token with, the subject and the two identity in it. And it's like, it's not going to serve that response. So the last thing I'm going to show you, which is what I was going to show you before, but I was rushing so fast. This is kind of the Indykite control plane, and here's just a picture of sort of the part of the graph that we were looking at. And so one of the things that in our world, context are these decision traces, but the context is also stuff like where did this data come from? So not only do we have in the customer account node the properties, but on the property we have the provenance of this. And so this sort of fourth dimension of the data is also, in my mind, a big part of the context. So if we want to basically validate the data and make sure that it's good to work with, we have trust scores and data validity that we can then use in queries. And we can make sure that the impure or unwashed data is not part of the decision-making process. Anyway, that's me. Hopefully I wasn't over, but yeah. Thank you.
Thank you so much, Dave.